So, just before the introduction now, we're going to look at gradient, which is a Cambridge word, so it's actually slope is what you're probably more familiar with. Now, there are some key formulas that you're expected to know. You might want to pause the video at this point and see how many of these you can remember. Any you got wrong, you'll want to make a note of. So, there's a formula for slope, y2 minus y1 over x2 minus x1. Remember rise over run as well, that would also be useful. There's your formula for midpoint. Basically, it's the mean of the x values and the mean of the y values. Distance formula, which is just a rearrangement of Pythagoras' theorem. And I put point slope up here just because it's a formula that we're going to use, and it's one that's not on the formula sheet. So the point slope formula is also useful, and it's assumed knowledge for this course. So none of those are going to be on the formula sheet that you're going to get for this subject. Also, types of equations. Now, we just talked about this one here, so we should recognise this one as the point slope formula. And these are the other different forms you should recognise as well. And that one's slope intercept, but we don't actually use that term in AICE, so you're not actually going to see that. They're going to say write it in the form y equals mx plus c. Also, when you did this in ALG1, they would have used b as well, so that might be slightly different for you too. If we've got x's and y's on the same side, but it equals a number, that's standard form. And if we have everything all on one side and it equals 0, then that's called general form. And there are a few extra rules. A, b and c must all be integers for these two here, and a must be positive for this one here. Although sometimes for the SOL they seem to overlook that point. Now there are a few key skills you need to know for this course. Really this should just be a review, so you can skip through these and write notes depending on what you think is relevant or not relevant. So if you have one point and a gradient like you can see here, or slope, point, slope, we're going to use the point slope formula, and then we simply substitute in the numbers. So y1 is my first y coordinate, which is 6, x1 is my first x coordinate, but notice if we're subtracting a negative, then that's going to become a plus. And m stands for gradient, and I have no idea why. We can go ahead and distribute this, and then we can add 6 to both sides, and we can make our equation look in slope-intercept form. Second method is, oops, you can probably see a little bit too much of that. Find the gradient of the line between 2 points. Essentially what we're going to do is the same thing we did in the previous question. We're going to find the slope first, and then use the same method. So using our 2 points, we can find the slope using y2 minus y1 over x2 minus x1. And then once we've got a slope, we can pick either point, and we can go ahead and find out what the equation is. Normally go for the one with the smaller numbers, so 1, 4 would make more sense. So substitute in, distribute, and then rearrange if necessary. If you have time, you should try also with a slope of 3 and the point 310 that you indeed get that same answer. Oops, a little too much of that one as well. So parallel lines, write the equation of a line parallel to one equation, passing through a point. Key thing about parallel lines is that they have the same slope. So if we start with y equals, we know this is slope intercept form, so we can read the slope straight from here. So in other words, the slope is just 2. And then now it's going to be the exact same method that you used on the previous question, that point slope formula. Now at the same time as we do parallel lines, it would make sense also to look at perpendicular lines. This is one that a lot of people half remember. So the slope for 2, if it's a perpendicular line, then you do the negative reciprocal of the slope. So 2 is going to become negative 1 over 2. So what we're doing here is we're taking 2, or 2 over 1. Reciprocal means we're going to flip the fraction here, and then we're going to change the sign. So that one's more complicated to do. If it was a fraction, it would actually be easier. So if I gave you 1/3 and asked you for the perpendicular slope, flip it, change the sign, and then 3 over 1 is of course just 3, so the perpendicular slope would be negative 3 for that one. Once we have our slope, we have our point, we can go ahead just like we did before. Go ahead and multiply this out, and then move to the other side. Our next key skill is intersections of lines. So where do these lines intersect? And what we have here is 2 equations with 2 unknowns, so this is actually a system of equations. Now if we're going to solve a system of equations, normally we have them in standard form, so x, y, and then a number. If it's not in standard form, you can rearrange this to make it into standard form. Now the idea is to make either the x's or the y's the same here. Now the easiest way to do that would be to multiply this equation by 3 to make the x's the same, Now 3x and negative 3x is still okay, we're just looking for the coefficient without a sign. Or we can multiply this equation by 2, and then that will give us 4y and 4y. So I think actually I have both methods up here anyway. So if I times this one by 3, make sure you times every term by 3. Then you've got a choice, do you add or subtract to make 0? So if we do 3 plus negative 3, that gives me 0. So make sure we add everything together. If 10y equals 30, divide by 10, we have y equals 3. And then to find the other value, we can now substitute back into one of these two equations. Shouldn't make any difference, but you want to substitute into the easiest one. I went with this one because the numbers were smaller. So 2 times y, 2 times 3 is 6. And then solve this equation, subtract 6 from both sides. Notice I have negative x, not positive x. So for the last step, make sure you divide by negative 1. If you do it the other way and times all this by 2, then we have this. This time we want to subtract the equations because 4 take away positive 4 is 0, 3 take away negative 2 is 5. You've got to be careful with negative numbers on these. 33 take away negative 2 is 35. X equals 7, just like we had here, so that's a good start. Plug 7 back into one of the formulas. I went with, let me just scroll back a little bit. I went with this equation here, so 3 times 7 is 21, plus 4y equals 33. Subtract 21 from both sides, divide by 4, and you can indeed see that you have exactly the same answer. So, systems of equations from Algebra 1 as well. Key skill 6, intercepts of lines. So to find a y-intercept, set x equal to 0 and solve. To find an x-intercept, set y equal to 0 and solve. I would put a big asterisk next to this. They love to ask this question on many different topics. So one you're going to be asked several times this year. So if you're asked to find the intercept of something that's in standard form, if we set x equal to 0, what we're really doing is making this 0. So we just get negative 2y equals 18, and if we divide by negative 2, that would give us negative 9. So the y-intercept would be negative 9. If I then set y equal to 0, I get 3x equal 18, so in other words x equals 6. That's how you find intercepts. So very easy to do actually. A few special graphs. So what do the following coordinates have in common? Well, if you were to go ahead and plot these, and I'm not sure if it's behind here or not. No, it's not. So I'm going to have to plot these. 2, 3 is up here. 2, 1 is here. 2, negative 2 is here. 2, 4 is up here. This one you have to give me a little bit of slack on. What you should notice is that they actually form a vertical line here. Now the key thing is, notice that the first number for each one is 2. And also the first coordinate is called x. So this line here, if I was to join it in, is actually called x equals 2. Now a lot of people get this wrong because the y-axis goes in that direction. So a lot of people mess that up. But notice you're passing through the x-axis at 2. Assuming I could draw that line accurately anyway. And that just summarises basically what I just said there. Now the alternative to that is this. This time notice I made all the second coordinates 1. So 0, 1 is here. 3, 1 is here. Negative 2, 1 is here. And 1 is here. And you can see that gives me a horizontal line. As the second coordinate is always 1, notice this is the y-coordinate. So what I can call this line is y equals 1. So horizontal lines all start with y equals. And then simply where do they pass the y-axis? They go through the y-axis at 1, so the equation is y equals 1. Even though the x-axis goes that way, it's still called y equals, and a lot of students do confuse that. And that's just a little summary of what was said there. Now if you're happy with all that stuff, then you should be able to go on to the exercise for this lesson and work on those questions.